A slope field is a way of sort of imagining what the tangent lines would look like. So let's create a slope field. For question number 1, we have a differential equation, and we know that this has infinitely many solutions. We know they're going to be arranged in a certain way, and we're told that wherever we have a point of tangency, the slope will be, well, whatever x plus 1 is. So if our function, wherever it is, happens to go through 0, 0, if I plug x is equal to 0 into this, it's going to give me a slope of 1. So that might be my tangent line. In fact, any place where x is equal to 0, here, 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 the tangent line will have a slope of 1. And if we are anywhere over here where x is equal to 1, we'll have a slope of 2. So I'm aiming for this, so something like that. Where x is negative 1, this is interesting, we're going to have a slope of 0. And that's something always to look for. Where is the slope equal to 0? If x is negative 2, I know our slope is going to be negative 1. If x is negative 3, our slope is going to be negative 2. So we get a slope field that looks something like this. And what I think of is something like a you may not know what a pinball machine is, but if you have a pinball machine, if you were going to send a little marble in here, it kind of looks like it would, at a certain point, bump along and follow a path, kind of like that, which is significant because I can find the original function for this. I would say dy is x plus 1 dx. Let's separate the variables. Let's take the antiderivative of each side, which is going to give me y is equal to 1/2 x squared plus x plus c. And this is, of course, a parabola, and we know that the vertex is going to be at, I'm going to go back and use that little algebra rule, at negative b over 2a, which is going to give me negative 1 over 2 times 1/2, which tells me I'm going to have a vertex at x is equal to negative 1, which is exactly what it looks like it should be. If we were going to look at what we have for question number 2, dy dx is 2y, so any place y is equal to 0, I know the slope is going to be equal to 0. Any place y is equal to 1, the slope will be 2, so something like this. Anytime y is equal to 2, the slope is going to be 4, so this gets progressively very, very steep. Where y is negative 1, the slope is going to be negative 2. And again, this is going to get more and more negative. So here we have a slope field that looks like this. Well, here we have a few solutions here that are kind of interesting. I know that if I shot a marble in here, it would, if it hit one of these, it's going to go up. So it looks like this could potentially be exponential. It looks like if I shoot it down here, if I have a point over here, this is going to be sort of a negative exponential function. And if I have a point right over here, it looks like I would have just a horizontal line. So it looks like I'm looking at 3 solutions, this one, or something like this. Well, let's look at the solution to this and see what happens. If I'm going to separate the variables, I'll be left with 1 over y dy is equal to 2 dx, which is going to give me ln, absolute value of y, equals 2x plus c, which is going to give me y is equal to c e to the 2x. And here's what's interesting. Suppose I knew that this was going to go through the ordered pair. Let's suppose it's 1, 0, right over here. If I plug 0 in for y and 1 in for x, well, the only solution to this is that c is equal to 0. So one solution to this differential equation is just y equals 0, which is exactly what we predicted. If I knew that this was going through the ordered pair 0, 1, I would have y is equal to c e to the 0, right? I'm sorry, 1 equals c equal to the 0, so c is equal to 1. So then our solution would be y is equal to e to the 2x. And on the other hand, if I knew this went through the ordered pair, let's suppose negative 1, negative 1, then I would have the equation negative 1 equals c e to the negative 2, which means I'm going to multiply both sides by e to the second. C is equal to negative e to the second. So the equation would be y is equal to e to the negative e to the second times e to the 2x. which is negative e to the 2x plus 2. But in any case, what's important here is that we're taking the opposite of an exponential function. So that works as well.